Welcome to the lecture series of Embedded Controller. So we are discussing about PIC microcontroller and programming. So today we are going to discuss about the important another register, that is status register. So far we have discussed about working register, that is WREG, which will be acting as an accumulator of microprocessor. In case of your microcontroller, it is REG. So similarly, the arithmetic and logic operations values, the status is given by this status register, where once the operation is done, the value will be maybe the positive value or negative value. It may be even number, it may be odd number, and it is having the carry and where it is to be added. So everything is given in the bit status, that is by the status register. So let us look on. So this is an 8-bit register. This is the bit configuration starting from bit 0 to bit 7. So bit 0 stands for C, that is carry, and bit 1 stands for DC, and bit 2 stands for Z, and bit 3 stands for OV, that is overflow, and this is for n negative. So let us discuss one by one in detail. If this particular bit is 0, then what it is the status, and if this particular bit is 1, then what is the status. So depending upon the bit value, whether it may be 0 or 1, the status of the ALU will be displayed. So now coming to the explanation. So as we have already discussed this. So last 3 bits are undefined. Only the first 5 bits holds the status, and last 3 bits are undefined, which may be 0 or which may be 1. Generally, it will be declared as 0. And the bit 5 to 7 is unimplemented. It is generally read as 0 only. And bit 4, that is n, stands for negative bit. So if we are doing 2's complement, it indicates the result is negative or positive. So if the ALU's MSB is 1, then the particular result is negative. So this particular bit will be enabled with 1. Then that ALU operation will result in a negative number. So if it is 0, then it is positive number. So by means of this 1 and 0, we simply identify the operation of 2's complement. Next, bit 3, OV shortly called as, it is overflow bit. So this bit is used for signed arithmetic again. So that is 2's complement. If it indicates an overflow of the 7th bit magnitude, which causes the sign bit to change the status. So that is, if the 8-bit of addition or subtraction is whatever the thing you are doing, if it is completed, once the 7th bit addition or subtraction is done, then automatically the overflow bit will be enabled. So the controller identifies that all the bits operations have been done starting from bit 0 to bit 7. So the arithmetic or logical operations, whatever is carrying out, it is completed by the controller. So if it is 1, then the overflow occurred for signed arithmetic, and if it is 0, that is no overflow occurred. So that is the representation of bit 3 overflow bit. When coming to bit 2, it is stands for Z, that is 0 bit. So if it stands for 1, that is if this particular bit is 1, then the result of arithmetic and logic operation is 0. And if it is 0, then the result of arithmetic and logical operation is not a 0 value. That is the indication of this bit 2. Next, coming to a bit 1, so it is DC shortly, and it is called as digit carry, that is borrow bit. So if I am adding two 8-bit numbers, so if the third bit, if you are adding the third bits together, then for example 1 and 1, so I am having 10, that is 0, and 1 is your carry, that is to be added to the next bit. So that will be indicated by this DC. Yeah, carry out from the 4th lower order bit, that is result occurred. No carry out from the 4th lower order bit of result occurred. Okay, so in between, if any carry is generated, that carry is handed is to be handed over by the next bit to the fifth bit. It should be shifted to the fifth bit. So that is done by this digit carry. If it is 1, then the operation results in carry. So that should be moved on to the next bit. If it is 0, no carry is generated. So the same operation can be found out. So this is very important bit in case of your addition or subtraction. Next, first bit, that is bit 0, is carry or borrow bit. So generally it is used in add WF, add LW and sub LW and sub, that is add value with working register, add literal value with working register, subtract literal value with working registers. So A1, if it is 1, a carry out of the most significant bit of the result occurred. So the difference between the bit 1 and bit 0 is, so this will indicate if the seventh bit, that is most significant, last start eighth bit. Okay, so if it generates carry, then it has to be added to the LSB or it has to be discarded depending upon the operation what we are doing. So at the MSB, if the carry is generated, this carry bit is enabled. Okay, so if it is 1, then carry out from the most significant bit of the result occurred. If it is 0, no carry out from the most significant bit is occurred. So this is simply a carry or borrow bit. So these two bits are very important, and the difference between these two is it will say the carry if present in between the bits. So it will say that the carry present is the most significant bit. It is 0 bit if the result is 0, overflow, that is all the operations have been completed, and negative bit if the status of that particular number is negative. So this value will be given by the status of your arithmetic and logical operations. Hope you understood.